Hey guys, so today we're going to recap how to solve two-step equations because that's going to be relevant tomorrow whenever we are working with um, algebraic expressions in those angles. And so I am pulling up some examples here on the computer, and we're just going to go through this real quick. So 3 plus 2g. Yeah, I live right next to a train, so I don't know if you can hear that, but trains come through at all hours of the day and night. Anyway, equals 5. So this is not the traditional way that we're used to seeing things. Normally we see the 2x plus 3, right? But it doesn't really matter because if you add 3 and 2, or if you add 2 and 3, or if you add whatever in any order, it's going to be the same thing. So the first thing we're going to do is draw this thing here, the line separating it. And we're going to, I guess, box cars and flatbeds. There we go. And so we want to remember move our single number to the other side. If we remember Beyonce, all the single numbers, they got to go first, so move them out first. Now, this 3 is actually a positive 3 because it doesn't say that it's negative. If it said it was negative, then that's the only thing that would keep it from being positive. Anyway, so in order to get rid of the positive 3, we have to use the inverse operation. So we are going to subtract 3 from both sides. Now, the one thing that I'm not super in love with about the boxcars and flatbeds is that it looks like division, and that's not what it is. So 3 minus 3, those cancel, and then we are left with 2g equals 5 minus 3 is 2. And then we divide by the number touching x. Well, instead of x, it happens to be a g, so we're going to divide by 2 on each side. Those are going to cancel. We get g equals 1. And so I have these problems pulled up here on IXL, and so that way I have very similar problems to what you guys are going to be doing here soon. And so I got my trusty eraser sock. There we go. Okay, there we go. So the next one, 2t minus 3 equals 1. All right, so again, I'm going to start with the equal sign river, and then I'm going to identify which one of these is my single number, which one is the constant, and that would be negative 3. Negative 3. But it's a minus. You said so when you read it. Yeah, it's a minus. It's also a negative. Those are the same thing. So 2t minus 3 is 1. So how do I get rid of something if I subtracted 3 from it already? Well, I add that 3 back. And again, I'm going to erase that little line there. Add that 3 back to both sides. And then those cancel, and I'm left with 2t equals 4. And then we divide by the number touching x, which in this case is 2, and we get t is 2. I know I keep saying x. Remember, that's our song. That's our mnemonic. So in this case, the variable is 2. And there we go. I'll get my sock back. All right. So far, so good. We're going to do one more together, and then when you have the hang of it, we are going to, actually, I'm going to go ahead and see if I can skip to the next level here. All right. All right, that's the same thing that we've been doing. Ooh, dang. I like this one. 4 equals q plus 9 over 9. That looks scary, doesn't it? So when we have division type problems like this, the very first thing we want to do, in this case, when the entire side of the equation is sitting on top of a fraction, we really need to get rid of this fraction thing. And so remember that a fraction is just a division problem. So we are going to multiply this entire side by 9. And whatever we do to one side, we do to the other. So those 9s go away. And 9 times 4 is 36. Okay, so 36 is q plus 9. That's just a one-step equation from here. So subtract 9 from both sides, and you get, I don't know, 27 equals q. And that is that. All right, now there is another kind like that. Let me erase this problem again. All right. So how about this one? We're going to actually do an x over 3 plus, I don't know, 5 equals 9. Great. Let's go 9. All right. So again, we're going to equal sign river. And then we have our positive 5 that we need to get rid of here. So there's the whole x term, and then there's that whole positive 5 thing, which we need to get rid of. The opposite of positive 5 then is negative 5. So we're going to subtract 5 from both sides. Bye-bye. So x over 3 is equal to 4. Here, x over 3, that's a fraction again. Okay, so when you have a fraction, remember it's just a multiplication problem, so we multiply both sides by the denominator. Again, that does mean doing this, but like why? 3 over 1, it's the same thing as multiplying just by 3. So we're going to multiply both sides by 3, and you get x equals 12. All right. Those are all of the examples that I have for you. So now hang on a second and let me get back to where I can see you. And you can see me. All right, guys. So you are going to be doing 7th grade math IXL number S6, which is two-step equations. Again, I need you to submit a screenshot that involves your SMART score, your name, and one of the problems that you're working on. So just take a screenshot at the very end there. And I would like you to get up to 80, a SMART score of 80. And that's going to include problems like this one with the division, and problems like what we just saw right before that one, where the whole side is on top of the division bar. Now, if you get in the 70s, that's still pretty good, but anything less than 70, and I'm going to have to start docking points. If you are spending an awful lot of time on these and still can't seem to get the hang of it, I insist that you Google Hangout me or email me, and we can get some of this worked out. All right, so that's it. I will see you tomorrow for more with angles, and that's pretty much all I got. You guys have a great rest of the day. Bye-bye.